Here is another set of data, and ang gagawin natin is to use the initial rate method in order for us to identify or find the rate law expression. So we have R equals K, concentration of A, concentration of B, respectively raised to alpha and beta, which are the orders of the reaction in A and B. So in this case, we have two variables. We have the concentration of A and B, so therefore we cannot really linearize easily our rate law expression, and you cannot really plot the logs of the concentrations and the initial rate. Well, we can do that mathematically, but it's quite complicated than what we did for reactions where only one reactant is in the rate law expression. Remember, in our previous example, we have two reactants, but one reactant is fairly constant, so we only considered one reactant. Now, anyway, for this set of data, we want to find again the rate law expression. So, one way to do this is we want to compare two rates or two reactions, and we have here reactions 1, 2, 3, wherein you were able to determine the data. So, we want to compare two sets of data one at a time. So, for example, let me consider first set 2 and 3. So if we're going to compare sets 2 and 3, what we can do is we can divide the rates for 3 over the rate for 2. So what I'm trying to say is mathematically that would be R3 over R2. Okay, so in this data, we have 5.92 times 10 raised to negative 6 divided by 5.92 times 10 raised to negative 8. Alright? Now, for the first rate, which is R3, it is expressed as, so if you can check the table above, the concentration of A is 0.28 raised to alpha. And then we have 0.046, which is the concentration of B raised to beta. Right? Divided by, now let's consider next yung R2. So sorry, it should be, 0.28 and 0.046, so that's all good. Now for R2, we have K times 0.028 this time, raised to alpha. And then the concentration of beta is 0.046, okay, raised to beta. Now, what will happen here is we can reduce this working equation. First, let's divide the left-hand side. So we have here 100, okay, equals, now we can actually cancel K as it appears both in the numerator and the denominator. And we can also have this expressions or terms vanish. So matitira na lang sa ating working equation will be 0.28 over 0.028 raised to alpha. So you can express that this way. So we have 100 equals 0.28 over 0.028. That's actually equal to 10 raised to alpha. So if we're going to solve for alpha, the answer will be 2. So therefore, we have now found the order of the reaction in species A. Now, yung beta na lang ang kulang, and that means we want to find the order of reaction in species B. So in that case, we need to find another two sets of data to compare to. And I will be using here 1 and 2. Okay, so let me first consider dividing R2 and R1. Okay, it's up to you if you want R1 over R2 or whatever, or you can actually select other data sets in the given table. But for R2, so again, R2, according to our table here, that's equal to 5.92 times 10 raised to negative 8. Well, the other rate, which is R1, the value that we obtained, okay, from the experiment is 7.40 times 10 raised to negative 9. So for R2 first, we have K times the concentration of A is 0.028. Just have to consult the table once again. Raised to alpha. And then the concentration of B is 0.046 raised to beta. And for R1, we have K. And if you look at the table, the concentration of A is 0.014 raised to alpha times 0.023. This is now the concentration of B raised to beta. Okay, so dividing these two values here, you will get 8. Okay? And we can actually cancel K. But aside from that, there's nothing else to cancel here, no? But we can express, or we can actually calculate this, no? So 0.028 over 0.014 will be raised to alpha. So I'm now trying to simplify the equation. And then on the other hand, we have 0.046 divided by 0.023 raised to beta. Okay, so simplifying this further, we have 8 equals 0.028 over 0.014 is actually equal to 2 raised to alpha. And the other one is still 2. So 0.046 over 0.023 is also 2 raised to beta. But we know alpha already, which is equal to 2 from our first comparison above. So let's go ahead and substitute that 8 equals 2 raised to 2 times 2 beta. Or 8 equals 4 times 2 beta. Or 2 raised to beta is equal to 4. So therefore, we will find beta. Sorry, it should be 2. And therefore, you will find that beta is now equal to 1. So we have found the orders of the reaction in A and B. So therefore, we can express the rate law as follows. That would be R is equal to K CA squared times CB. So this is now our rate law expression.